What we're going to work on today is a topic called reference angles, or actually radian measure. The last time we had a video, it was on reference angles, and that's what I would like you to do first as you're due now. So what I'd like you to do, let's take a look at the two questions. The first one says, find the reference angle for 305 degrees. And then number 2 says, find the reference angle for negative 205 degrees. So take a moment, give those two a try, and we'll see how you do. If you want, you can pause me. Okay, so I hope you pause me. And what we're going to do here is sketch this. So make an X and Y axis, right? 305 degrees, so this is 0, right? So 0, 90, 180, 270, so 305 is going to be about here. All right, so this was 305 degrees. Now remember, for a reference angle, you have to create a right triangle. So I'm going to draw this red line, and the right angle has to touch the x-axis. So we need this little corner here. That's the reference angle, this little guy here. So notice, a whole way around a circle is 360 degrees. We didn't quite make it. So I'm going to do 360 minus 305. And that means this little bitty sliver of an angle is 55 degrees. And that's the reference angle. So if you didn't get that correct, although a lot of you did a really nice job in the homework, so I feel like you do understand this. But if you messed that one up, pause me again and give this one a try. All right, so hopefully you paused me or you did this one on your own. Graph it. Okay. Negative 205 means I'm going backwards. I'm going down. So from here to here, negative 90, negative 180. So negative 205 is going to pull me to about there. All right, so this was negative 205 degrees. Okay, I'm going to draw my triangle. And remember, the right angle goes against the x-axis. So I need to get this red corner right here. Well, how far was it from here to here? That was 180, but we went a little bit past 180. So if I do 205 minus 180, I get 25 degrees. And that means that little corner is 25 degrees. That's our reference angle. So that's what we did last time. What we're going to talk about today is something called a radian measure. Now, think about a ruler for a minute. You know how on a ruler, one side of it is inches and the other side of it is centimeters, right? There are two different ways of measuring something, either the English metric system, or the metric system. Well, there are two different ways of describing an angle. Up until now, we said an angle is 300 degrees, 25 degrees. But now we're going to start talking about a new way to describe an angle. We can say an angle is pi over 6 radians, or 7 radians. So, here we go. Radian is another way of an angle. So radian is going to be a whole new way of describing the size of an angle. So we can say something in degrees and something's in radian. An angle is said to be 1 radian in measure if the intercepted arc has the same length as the radius of a circle. All right, so let me explain what that means. Let's say we have a circle, right? Okay. And I say this is 8 centimeters. So I take a ruler and I measure from here to here. The radius is 8 centimeters. And then I'm going to draw a central angle. So this is my theta. Okay. Right here, this section I'm squiggling in red. If I were to take a ruler, well, actually first I'm going to take 2 scissors and go snip, snip, and I take this red piece and I measure it. This also is 8 centimeters. So anytime we have a circle and we have a central angle, if this arc right here is the same length as this, theta equals 1 rad. Okay? So there's a formula we get from this, and the formula is theta equals S over R, where S stands for arc length, and R stands for radius. And you should have done something like this in geometry last year. So what I'm going to do is we're going to talk about how this has to do with angles and degrees. So let's talk about our good friend the unit circle. So let's take a circle. And what's special about the unit circle? How big is the radius? I hope you remember the radius on the unit circle is 1. All right. So what we want to do is figure out how many radians is 360 degrees. So 360 degrees in a circle is the whole way around. So I want to take the whole way around in this guy. Now, we know the radius, that's this guy. So I'm going to do theta equals 1 over, right, it's the radius. But S is arc length. S is the whole trip around. And the whole trip around in a circle is the circumference. And there's a formula for circumference, which is 2 pi r. Now, r is the radius. Now, since the radius is 1, so the circumference of the unit circle is going to equal 2 pi times 1, which is 2 pi. All right, well, that's the arc length for the whole way around this unit circle. So that's the S. So I'm going to put 2 pi there. Well, what's 2 pi divided by 1? That's 2 pi radians. Now you're probably thinking, why is that important? Well, what that means is, what did we say a whole way around the circle was in degrees? 360. Well, that's a whole way around a circle now in radians, 2 pi radians. So that means anytime you see 360 degrees, you can rewrite it as 2 pi radians. They're equal to each other. So if 360 is 2 pi, what do you think 180 would be? That would be 1 pi radians. Right? Would it be 90 degrees? Well, that would be half of that. So instead of writing a half pi, we usually write pi over 2 radians. So what we're going to do now is practice converting back and forth from degrees to radians. So what we're going to do next is I want to convert, let's do 40 degrees to radians. Okay, so what we're going to do is we're going to take 40 over 1, and in order to convert it, you're going to multiply it by pi over 180. So, we'll start here. To convert from degrees to radians, multiply by pi over 180. All right, so what that does now is that makes 40 pi over 180. Okay. The zeros will cancel, so I get 4 pi over 18. And then what do 4 and 18 have in common? I hope you're thinking 2. So this becomes 2 pi over 9 rad. And there you go. So that's how you convert degrees to radians. Well, I'm going to leave a little space here and put another star. So leave some space. Now I'm going to convert 2 pi over 3 rad into degrees. So what if I want to go the other way? Well, since I want to go the other way, all we would do is take 2 pi over 3, and we're going to multiply it by 180 over pi. We're going to do the flip of this. So I'm going to write it here. So to convert from radians to degrees, multiply by 180 over pi. So let's try this one now. Now, when I come over here, the beauty of this is, look, the pi's cancel. What's 2 times 180? It's 360 over 3. And that divides to be, look, 120 degrees. And we're all set. So what I want to do now is practice a couple of these. Convert the following degrees into radians. All right, so we're going to convert a few. So let's do 60 degrees. Then we'll do, how about 300 degrees? And then we'll do 225 degrees. All right, I want to convert these 3 into radians. So why don't you pause me for a second and give those a try. All right, so I hope you pause me so you can do them on your own. I'm going to take 60 degrees. So I'll do 60 over 1 times pi over 180. Okay. That makes 60 pi over 180. Now, for those of you who don't like reducing, we can use our calculators to help us. Let me clear that. What you can do is do the fraction button and just put 60 over 180. Don't put the pi in. And it'll reduce the fraction. It'll say 1 over 3. So that means I'm going to have 1 pi over 3 rad. Okay. So let's try the next one. Do 300 over 1 times pi over 180. That makes 300 pi over 180. And again, if you want to use your calculators to help you reduce, do the fraction button. Put 300 over 180. Again, don't put the pi in, just the numbers. And it says 5 over 3. So that makes 5 pi over 3 rad. Okay. And this would be 225 over 1 times pi over 180. So that's 225 pi over 180. Use our calculator again. Fraction button. 225 over 180. It reduces it to be 5 over 4. So I'm going to write 5 pi over 4 rad. Okay, now what I would like you to do is we're going to do some radians into degrees. So, let's say, convert the following radians into degrees. Okay, so let's do 3 pi over 2 rad. Okay. Number 2. We'll do 7 pi over 4 rad. Number 3. Let's do that one. I'm trying to come up with some good ones. Let's do 5 pi over 3 rad. And finally, we'll end with 5 rad. Just plain old 5. All right, so what I'd like you to do is try these 4. You can pause me. And let's see what degrees you end up with. Okay, so I hope you pause me. do 3 pi over 2 times. Now you're going to multiply it by 180 over pi. You're going to do the reciprocal. These cancel, right? Then you're going to do 3 times 180. Right? You can just put it in your calculator if you want, right? We can even do fraction button 3 over 2 times 180. And I'm getting 270 degrees. I'm going to do 7 pi over 4 times 180 over pi. Again, if you do it right, the pi's cancel for these. Okay. Now, in your calculator, do 7 over 4 times 180. This one should be 315 degrees. 5 pi over 3 times 180. This one's 300 degrees. Okay. And finally, this one's a little weird. You're going to put 5 over 1 times 180 over pi. Now, unlike all the other ones, the pi won't cancel. We're stuck with it. So we're just going to multiply straight across. I'm going to do 5 times 180, which is 900. 1 times pi is pi, and believe it or not, guys, you can leave it like that. That would be 900 over pi degrees. So it's a funky looking answer. And that's how you convert back and forth from radian to degrees. So for homework, I have a couple of these for you guys.